Hello everyone and welcome to my lecture Internet of Things. I'm Neda and today I'm gonna talk about Raspberry Pi Pico W pinout diagram. So let's start. Okay. Here you can see the Raspberry Pi Pico W pinout diagram. Raspberry Pi has 40 pins which are labeled on the underside of the board, and 3 labeled exist on the top of the board, as you can see 1, 2, and 39. Pin 1 and pin 2 and pin 39 you can see on the board, and these top labels help you remember how the numbering works. Pin 1 is at the top left as you look at the board from above, with the micro USB port to the upper side, and pin 20 is at the bottom left here, and pin 21 the bottom right here, and pin 39 is one below the top right with the unlabeled pin 40 above it. So you can remember it very well from 1 to 40. This Raspberry Pi Pico exposes 26 multifunction 3.3 volt general purpose I/O or GPIO. It means that they can be programmed to act as either an input or an output and have no fixed purpose of their own. Most of GPIO pins have extra features and alternative modes for communicating with more complicated hardware, such as screens, and also offer secondary functionality for SPI, as you can see here in this color, pink color, and I2C, the blue color, and also UART in this purple color. Communication protocols. So you can see that other pins have a fixed purpose, providing connections for things like power, like these red ones. 23 GPIO, which means GP 0 to GP22 are digital only, and GP26 and here, and to GP28, I mean GP26, GP27, and GP28 are able to be used either as digital GPIO or as ADC. As you can see, we have ADC, as I explained you ADC in the previous lecture. It can be rolled as ADC, these pins. So you can select in the software that it can be ADC also, can play as a role ADC. So ADC, I will explain it again, is an analog to digital converter and is a device that converts an analog signal, such as a voltage, into a digital representation that can be processed by a digital electronic system. ADC works by taking samples of the analog signal at the regular intervals and then quantizing and encoding each sample into a digital value using a mathematical algorithm. The output of an ADC is a binary number that represents the original analog signal in a digital form, which can then be manipulated, stored, or transmitted using digital electronics. And we also mentioned that resolution of an ADC refers to its ability to accurately represent a range of analog values with a corresponding range of digital values. For example, we had a 10-bit ADC that can represent 1024 different values from 0 to 1023, and a 11-bit ADC that can represent 2048 different values from 0 to 2047, and allows that capture more detail and provide a more accurate digital representation of the analog signal. Also, I want you to note that when you are programming, when we are going to program the microcontroller like Pico, you should always notice the mapping between the pin number to the GPIO number in your code. For example, you go and write a code that you need to work with the GPIO pin 3, and this is pin number 5, but it is GPIO 3. So in the code, you should be careful. If you are mapping to this pin, this is GPIO 3, and you shouldn't use the number 5. So we will more explore in the MicroPython programming section. Okay. So you should remember this Pinout diagram. Have a good screenshot of this in your mind, that when you are going to work with this, you should know that they are GPIOs, and we will have SPI, we will have I2C and UART. In the next slide, that is a categorization of the Raspberry Pi Pico W pins. We have power pins, we have GPIO pins, and other pins. From the 40 pins, we can have 3 different categories. One is power pins, and one of the power pins is VBus, that is pin 40. Let's look at this picture from this side. 40 is VBus, as you can see here. And it's a pin used to power the board via an external power source. It can accept a voltage range of 4.8 voltage to 5.5 volts. The other one is VCs or V-system. That is pin number 39 here. It's a V-system. And it's a pin directly connected to your Pico W internal power supplies. That is the chip RP2040. And this RP2040, exactly the pin is connected to pin 39, and it cannot be switched off without also switching Pico W off. So this VCs here exactly is connected to your RP2040 pins internally. And the other pin is 3.3 volts underline enable, which is pin 37. Let's see here. This is pin 37, 3 volt 3 underline EN. And it's a system control pin that is responsible for both switching on and off the internal power supply, which means VCs, and also the 3 volt output pin, which means 3V3 out. And I'm going to say that what is 3 volt 3 out pin. 3 volt 3 out pin, which is pin 36, as you can see here. This pin I am going to talk. It's output pin that can be used to power external components that require this voltage. Let's think about a device, electronic component is connected to your Pico W and needs 3.3 volts voltage, and that component can get this voltage from your Pico W. So that's why it is called out in the diagram. 3V3 out. And it can be switched on and off using the 3 volt 3 underline EN. EN means enable pin above it. And this is so this pin 36 is controlled by pin 37 for switching on and off. We have ground, and they are the pins 3, 8, 13, 18, 23, 28, 33, 38 that provide a reference potential for the circuit. Look at here. We have this ground, which is pin 3, pin 8, pin 13, pin 18, pin 23, 28, and 33, and also 38. So we have 8 ground pin. Other category is GPIO pins. As I mentioned before, we have 26 general purpose input-output pins that can be configured for various purposes, such as I2C, SPI, UART, and more. And they are from GPIO 0 to GPIO 28. And these pins are our GPIO. As you can see in this photo, GPIO 0, 1, these colors you can see, on up to 28 here. The next category is we have other pins that serve specific purposes, like boot cell. And this pin is used to select the boot mode of the board. When we need to go to the boot cell mode, we will use this button, and it's here. This is boot cell, you can see here. And also we have a LED that's connected to GPIO 25. We don't have here GPIO 25. I mentioned before why. And so one of the GPIO 25, the GPIO 25 is connected to our LED. This is LED that is built in and exists on your Pico W. So it was the categorization of our Pico W, and here I wrote some summary of it. If you like, you can read this table, but I explain every different pin separately. Okay, it was a whole lecture about, and thanks for your time. If you have questions, please Slack me on the groups that we have and the channel, and goodbye.